Okay, part 4 of the review is going to cover rate of change and functions. So the first thing I'm going to do is we're going to look at some graphs. We're going to interpret the X-intercept, the Y-intercept, and slope, and what they mean as well. It's very crucial that we understand what they mean. So let's look at our first graph. We're talking about the cost dollars and the average rating of whatever it is that they're referring to. Okay, the X-intercept is the place where this function is crossing or intersecting with the x-axis, which is right down here, which is at the value 1. So our x-intercept is x equal to 1. Now, what does that mean? What that means is that the cost essentially is starting at $1. You don't see anything below that, right? And at the average rating of 0, the cost starts at $1. So represents, I guess, how would I phrase this? Represents cost starts at $1 for rating, I guess, if you will. All right, Y-intercept. Now the Y-intercept is where it hits the y-axis, where this function here is intersecting the y-axis, and that doesn't happen at all. As you can see, it doesn't hit the y-axis anywhere. So there is no Y-intercept, right? None. Don't say 0, because if you say 0, then you're implying that maybe it hits down here, but it doesn't. Y-intercept represents. Well, since we don't have a Y-intercept, we'll kind of cut this out as well. If we had a Y-intercept, though, it would essentially be the rating that we get for free, if you will, or the rating that you start with for $0. So, like, for example, if the graph did something like this and the Y-intercept was 3, that would mean that cost $0, so you wouldn't have to pay anything, and there would be an average rating of 3. It's kind of what that implies. Now, the slope of this line, it's, we kind of have to interpret it the best we can, but we'll say from, let's see here. Let's pick a point, right? So at 1, 0 to 2, what looks like maybe 5.5, right? So that's an increase in 1 for the x-axis and an increase in 5.5 for the y-axis. So essentially, right, you're going up 5.5 and then you're going over 1. That's a slope of 5.5 over 1. You can maybe, if you guess 5 to 1 or 6 to 1, that'd be okay. But we're guessing here. It's about 5.5 as you go over 1. So that's our slope. Now our slope represents the increase in rating per dollar, essentially. So the increase in rating per dollar. Essentially, this is increasing by 5.5 rating per dollar, right? Because you only went up $1 from 1 to 2. But that jump, oh, it looks like it's actually about 5. Maybe I did that bad. It looks like it's probably closer to 5. It's really hard to read on this graph, but we'll say 5 to 1. Okay, or just 5. So basically what it's saying is the rating will increase 5 for every dollar that is spent. All right. Now let's look at the second graph. We're talking about percentage of adults who smoke and years since 1945. Now, it's important to reference here is the years since 1945. 5 years after 1945 really makes this year 1950. 10 years after 1945 really makes it 1955. 15 years after 1945 really means that's 1960. So keep in mind that these are actually years themselves. 40 years after 1945 would be 1985, right? So just keep that in mind when we answer some of these questions. All right, so X-intercept. There is no X-intercept. There's nowhere this line hits the x-axis, so there is none. But if there were, essentially what that would mean is that would be the year at which all adults stop smoking. Percentage would be 0 adults smoking, and it would be the year at which the adults would stop smoking. So there isn't really interpretation for this, but if there was, it would be that it would essentially be the year that all adults stop smoking. The Y-intercept. Now, the Y-intercept is over here. Now, that's clearly around 40, right? Really, really close to 40, maybe like 41 or 42, but we'll say it's about 40, right? So we'll say Y equals 40 is our Y-intercept. Now, what does this represent? Well, it means that, remember, this is at the beginning year, right? This is 1945. It means that there's 40% of adults who smoke in 1945. So 40% of adults smoked in 1945. And then let's look at our slope. So assuming that was 40, let's pick a different one. Let's pick that 20. Let's go there, right? So 20 years go by and about 10% decrease in smoking, right? Roughly. It's an eyeball, right? But it looks like it's going down 10% over the course of 20 years. So our slope essentially could be, if you reduce that 10 over 20, can be like 1/2. Or essentially what it represents is saying that the percent of adults that smoke decreases, actually going down, it's a negative slope, decreases by 0.5% per year. So percentage of adults that smoke, percentage of adults who smoke decreases by 0.5% each year. There we go. All right. Our third graph, saving money. All right. So X-intercept, again, you can see that this graph here, it has no X-intercept because there's nothing hitting the X-axis, so there is none. If there were, though, let's say that the graph started with something like this, that would mean that they started saving on week 4, right? Essentially, they have 0 saving for the first 4 weeks, and then on week 4, that's where we're kind of marking the beginning. So if there was an X-intercept, it would represent the time at which the amount of money they started saving began. All right, Y-intercepts. We do clearly have a Y-intercept where it hits the Y-axis. This line hits the Y-axis at about 30. So the Y-intercept, we'll say Y equal 30. And what does this represent? Well, it means that, remember, this is 0 weeks. So at the beginning, right, the amount of money saved is 30. So essentially, they're starting off with $30 saved. Start with $30 saved. Now, what is the slope? Again, just find 2 random points that are easy to use. I would say maybe the 0, 30. And it looks like the 240 is also really useful. So what is this? This is an increase of 10 over the course of 2 weeks, right? So an increase in 10 over the course of 2 weeks, or essentially 5 in 1 week. Now, what that represents is that they're saving $5 per week, essentially, right? $5 per week. They save $5 per week is what this represents. Okay, so slope, make sure when you're doing slope, you identify 2 very clear points. You can even pick different points, like 345 and 870, right? Those are a little harder to use, but essentially you can see that from 45 to 70, that's an increase in 25 over the course of, from 3 to 8, that's 5 weeks. And it's the same slope, 25 over 5. $25 in 5 weeks, that simplifies to just $5 per week again. So you can use any points that you want. Just make sure you reduce it so you can interpret what the slope really represents. All right, let's go to the second side of this. All right, drew scuba tank, X-intercept. We have an X-intercept. It's here at 6. X equals 6. Now, what does this represent? Well, if this is the amount of air in the scuba tank, right? Well, on the x-axis, it would be 0 air in the cubic tank at 6 minutes. So what that means is it will take 6 minutes for the tank to run out of air. It takes 6 minutes for tank to run out of air. There we go. The y-intercept. The y-intercept is here. That's at 40. So y equals 40. Let's put y equals 40. Now, what does that mean? Well, again, this is at the time 0. So time 0 is always the beginning. Our air is at 40 cubic feet. So what it means is that we start with 40 cubic feet of air. We start with 40 cubic feet of air. Okay, that's the beginning, and it's the amount at the beginning. We have 40 cubic feet of air at the beginning. Now, what is our slope? So a couple ways you can look at this. Let's start with 40, 0, and maybe even 320. Those look good. So if I pick those points, then what it is a decrease in 20 over 3 minutes. So it's a decrease in 20 over 3 minutes. This doesn't simplify very nicely. I believe as a decimal, it would be something like, negative 6.6 repeating. I think. Don't quote me on that, but I think that's right. So it doesn't really help. But what it does represent is the amount of air lost over time. The amount of air that we're losing over time. Amount of air lost over time. Right? To be more specific, it's about 6.6 cubic feet of air per minute. You could just say it loses 20 cubic feet of air every 3 minutes. You could say something like that. So there's different variety of this. It doesn't simplify very nicely our fraction, which is what makes this a little more complicated. But at the end of the day, it is the amount of air that's being lost over a specific period of time. Leaking tank. So this is basically how much is being leaked out over time. Now our x-intercept here is at 0. Hits the x-axis at 0 on the x-axis, which is also, you might notice, the same on the y-axis, right? The y-axis at 0, the x-axis at 0, they all kind of collide here. So the y-intercept is also 0. Let's go ahead and put that on there while we see it. All right, now what does the x-axis represent? Well, essentially, these are both representing the same thing, but the x-axis represents specifically the time when there's no gallons leaked out, right? Time when no gallons leaked, which in this case is at 0 because it's at the beginning. It's leaking over time, so the only time it wasn't leaking was necessarily kind of like at the start where it was like full, right? What does the y-intercept represent? Well, the y-intercept represents gallons, or essentially gallons leaked at the beginning, because remember x is 0, so it's the gallons that are leaked at the beginning. Gallons, but again, this is 0 because at the very beginning, that's when we're starting the little clock, starting the little timer. We didn't leak any gallons at the beginning. We didn't start with 2 gallons already leaked out, right? For example, if it was here, that would say, hey, at the beginning, we've already lost 4 gallons of gas. So gallons leaked at the beginning. In this case, it's specifically 0 gallons leaked at the beginning. The slope, well, they gave us 2 points pretty nicely. So we have a slope, we have a point at 4.3 and 8.6. So that's an increase in 3 and a run in 4. So this is essentially saying, if we take a look at this, 3 over 4, essentially saying that we're leaking 3 gallons of gas every 4 minutes. So leaks 3 gallons every 4 minutes. If you wanted to simplify that, you would say you would leak 0.75 gallons per minute, per 1 minute, 0.75 gallons per minute. Or you can say this, it leaks 3 gallons every 4 minutes. Essentially, it's the amount of gallons that are leaked over time, similar to the last one. We have one more graph to interpret, X-Intercept. There is no X-Intercept because the graph is way up here. So there is none. Now, again, just to interpret what it means, let's say it was here, for example. Basically, what if this is kind of a funny one. If it was this purple line that I just drew and it started at 2, the X-intercept was 2. Essentially, it would mean that the mood rating, this person is not having fun for 2 hours, right? The mood rating is at 0 until 2 hours, and after 2 hours, then their mood rating goes up. So that's sort of what the X-intercept would represent. Now the Y-intercept is here at 5. So this indicates that at the beginning, right, time 0 again, at the beginning, we already started with a mood rating of 5. So we're maybe we're kind of happy. We're content. We're in the middle. We're feeling okay. Not bad, not good, but all right. And then we start playing sports and our mood increases, right? But essentially at the beginning, our mood rating is 5. All right, now what is a slope? So again, I'll try and find some useful ones. So I'll use this Y-intercept. You know that's 0, 5, and then maybe the one at 2. There you go. That's a good one right there. Right, I'm just trying to find any 2 points. Not the points that they gave us, just something that's on our line. I'm not looking at the specific points, but 0, 5, and maybe like 2, 8. Those seem like decent points. Now that would be an increase in 3 for the mood over the course of 2 hours, right? So you can say, let's say 3 over 2, and that's good. That's not simplifiable. I mean, you can make it 1.5 if you want. You can change it to 1.5 if you like, but what it represents is that our mood rating increases by 3 every 2 hours, or it increases by 1.5 each hour. You can think of it like that. However, either answer would be fine with me. Increases 3 over 2 hours, or you can say increases 1.5 each hour. Either is fine. So I'll let you guys write down whatever you want to write down there. One of those two is perfectly fine. But it's the increase in the mood rating over a particular period of time. All right, now determine whether this is a function or not. All right. So the first one is yes, a function. Here's how you can tell. What makes a function is that each x value is paired to one exact y value. So the x value of 2 is not paired to anything other than 5, right? Because if you look at the rest of the points, there is no other x value of 2 paired with a different number, right? And same thing goes for all the other, right? 4 is only paired to the 6, 3 is only paired to the 10, 11 is only paired to the 9, right? So basically, there are 4 unique x values. Whenever you have 4 different x values, you're always, or 5 or 6 or whatever, if they're all different x values, then it's going to be representing a function because there's no duplicate or cloned x. And notice, I don't really care about the y's. I'm only focused on whether there's a clone or duplicate x. This is a function, yes. And when you explain, you can say, because each x has only one y value. And if you're confused by what I mean by that, it's like you're thinking common sense, like, duh, they only have one y value. I don't see 2 y values there. You'll see what I mean in what's coming up. Not the second one, though. Second one is still a function. This is still, yes, a function. The reason for it is because you'll notice that there are 4 all different x values, 0, 1, 2, 3. So the x value of 0 goes to 5 and only to 5. The x value of 1 goes to 5 and only to 5. X value of 2 goes to 5 and only to 5. And x value of 3 goes to 5 and only to 5. Remember, it's each x is paired to one y, not each y is paired to one x. Okay, so it's very important that you make that distinction between those. This is a function for the exact same reason as the last one, because each x has only one y value. If you're wondering, remember, like I said before, when we first studied this, is think of the x's like people, so the 0, the 1, the 2, the 3 like people, and then think of the y's like places. So you can have multiple people go to the same place. That's completely reasonable. But what you can't have is the same person going to more than one place. And that's what we're going to see here in this third one. The third one is a no, okay? Because you have 0 that goes to 5, 0 also goes to 6, 0 also goes to 7, and 0 also goes to 8. 0 is a person, and it's at 4 different places at once. 5, 6, 7, 8. So it's the opposite of what we saw in the second one, right? This is 0 is the x values, and then you have 5, 6, 7, 8 as the y's. So remember, x's are like people, y's are like places. So 0 is at 5's house, 0 is at 6's house, 7's house, and 8's house. Now you can't have that. You can't have a person going to multiple places. But you could, in what we saw in the last problem, you can have multiple people going to the same place. You know, this one here on the right is fine. The one here on the left is not. Note the difference, though. It's a very distinct difference. Okay, so the reason we're going to say is x value of 0 has multiple y values. Remember, it's supposed to only have one unique one. Looking at the fourth example, negative 9 goes to 3, negative 4 goes to 11, 4 goes to 15, and 9 goes to 18. Again, what's a good giveaway is that we have all different x values. That's good news for us. That means it's a function, okay? So again, same reasoning as the first one, okay? You can just rewrite that if you want. Each x value has only one y value. The fifth one, negative 1 goes to negative 7, 0 goes to 12, negative 1 goes to 5, negative 2 goes to negative 4. Hopefully you guys can see it. This one is not a function, okay? And the reason is the x value of negative 1. It goes to 2 places. Negative 1 goes to negative 7, and it also goes to 5. So as a person, negative 1 is in 2 places at once, and that can't be. That's kind of like exactly the same thing we saw from the third example. So x value of negative 1 has multiple y values. And then the last one, negative 4 goes to negative 5, negative 2 goes to 1, 2 goes to 1, and 4 goes to negative 5. Again, the point here is looking at the x values. They're all different. Negative 4 is only going to negative 5. Negative 4 doesn't go anywhere else. Negative 2 goes to 1. Again, there is no other negative 2 that goes anywhere else. Positive 2 goes to 1, which is fine, and 4 goes to negative 5, which is fine. Again, if you're looking at kind of a map of this, you'd have the x values are negative 4, negative 2, 2, and 4, and the y values are just 1 and 5. Remember, it's okay. This is okay to have multiple people go to the same place. Negative 4 goes to negative 5. Negative 2 goes to 1. Positive 2 goes to 1. And 4 goes to negative 5. This is okay. Each x value as a person is going to one place. You know, you have 2 people at one's house. You have 2 people at negative 5's house, but there's nothing wrong with that. Each of these people is in one place, though. That's the part that matters. As long as they're not in 2 places at the same time, you're good. So again, you can just write this is yes, and you can just say because of each x value has only one y value. And the last one is the vertical line test. Is it a function, yes or no? So essentially, your explanation can just say passes vertical line test or fails vertical line test, but draw the vertical line to prove it. So the first one is yes, because a vertical line is a straight up and down line, and no matter where you put your vertical line, it only ever hits the function in one place at a time. Okay. So when you explain, you can just say passes vertical line test. Pass vertical line test. Okay. All right. And then draw a vertical line to prove it. This one, second one here is a no, because it is a vertical line. It clearly fails the vertical line test because the vertical line hits the entire line. So definitely more than 1 point. So we can say fails the vertical line test. Again, draw the vertical line on there so that we can prove it. Third one is definitely not, because you can draw a vertical line and you can hit more than one place on your function. So there's multiple places where your vertical line would show that the function fails, but you only need one vertical line to show that the function fails. So one is good enough. The fourth one is yes, a function. Again, the vertical line test passes. If the function continued down here and was a circle, then it wouldn't. However, it stops, meaning that no matter where I draw my vertical line, I only hit the function in one place, which is good. So that one can be tricky, but it's only a function because it cut off the bottom. If it kept the bottom of the circle, it would have failed this. Oh, and that's what you see in the next one. They kept the bottom of the circle. That one clearly fails. Those two places. The sixth one passes because the vertical line will only hit the graph once anywhere you go. The seventh one is going to fail. Right here, for example, hits the function twice, so that's not going to be a function. And then the last one passes because the vertical line will only hit the function one place at a time. No matter where you draw your vertical line, only hits the graph one place at a time. So that's the result. That's the review sheet for you. A little shorter, I think, than the other ones, but still very, very important. Make sure these are some easy questions on the test for the X and Y intercept and the determine whether it's a function or not. So good luck with it. If you have questions, again, let me know. I'll see you guys soon.